So here is the second stoichiometry worksheet that we do here. These will involve two-step problems, but try not to think about it in terms of how many steps we have to do, but just do one step at a time. First, we start with the number that's given to us, 320 grams of O2, according to this very fun chemical reaction here, decomposition of potassium chlorate. It's actually very exothermic and potentially explosive. But here it's 320 grams of O2, X, line, drag down the unit. Question is asking how many moles is used to produce those 320 grams of oxygen. So you write down KClO3, potassium chlorate up top, and the question is, well, how do I convert grams to moles of something else, grams of oxygen to moles of potassium chlorate? Very quickly, you need to learn that you cannot go from grams of something to grams of something else. What you can convert grams to, and really the only thing you can convert grams to when it comes to stoich, is moles of itself, meaning grams of O2 to moles of O2. And then use the molar mass for 1 mole is equal to 31.998. That's the molar mass that you find on the periodic table. And so one step was not enough to do this. Moles of O2 is not moles of KClO3, so I need a second step. X line, drag down the unit, moles of O2, moles of KClO3. And now I need that new true statement to solve this problem. How do I go from moles of something to moles of something else? How many wheels do I need for a bicycle? How many wheels do I need for a tricycle? That number to number ratio is what I'm looking for, and that's what this number is here. 2 moles of KClO3 will produce 3 moles of oxygen. And then you can go ahead and draw your diagonals again with some enthusiasm, perhaps. Grams O2 cancel out, moles O2 cancel out, and you're left with moles of KClO3, and that is what we're looking for here. And then you type that into your calculator, and you get to 2 sig figs 6.7 moles of KClO3. So that's one type of problem where first we did molar mass and then we did molar ratio. The other type of problem is going to be just the opposite. Remember, all the steps that we do, it's not a matter of always using molar mass first, always using molar ratio second. Moles always on top, 1 always on the top. The things you always do is convert 1 unit at a time. What we have to learn is how to do that. So here's another question here. How many grams of O2 is produced from the same reaction, 0.02 moles of KClO3? So now I'm asking for grams of O2 as opposed to being given grams of O2, and asking for moles of KClO3 instead of being asked for it. So I write down what's given. 0.0204. That's a little sloppy, even for my standards. 0.204 moles of KClO3, also known as potassium chlorate. X line, drag down the units. And now what can we convert this to? We can convert moles to molecules or grams of KClO3, but we're trying to get to grams of O2. So I put grams of O2 on top, except that I cannot convert moles of something to grams of something else. And so to convert from 1 molecule to another molecule, I have to use this mole ratio. I realized in number 1 we did the mole ratio second, but this is telling us we have to do it now. Extra line drag down the unit puts moles on the bottom, and I have to convert to moles of oxygen before I can convert to grams of oxygen. And again, the coefficients give me my mole ratio, 3 and 2. I'm not done yet, so X line, drag down the unit, trying to convert to grams of O2. And now I have to convert moles to grams. How do we do that? That's with the molar mass. 1 mole is equal to 31.998 grams of O2. You can draw your diagonals. Moles KClO3 crosses out with moles KClO3. Moles of oxygen crosses out with moles of oxygen. I'm left with grams of O2, which is what the question asked for. So now I can pull this into my calculator, round to proper sig figs, and you get 0.979 grams of O2, like my answer gives us. Again, it's when you're trying to learn a new process, you're trying to learn the steps, and I get that. I get there's quite a few steps also. Some things are repetitive, some things are different. The numbers, the chemicals, those are different for each question. What to do first is not different for every question, but you have to know what to do first by looking at what the question is asking you. In this case, moles is being asked. That went last. Grams was given, so using a molar mass to convert to moles was first, as opposed to number 2, moles was given to us first, and so I need to use my mole ratio to convert to moles of the other object and convert to grams last. You have to really read the question. What comes first may or may not be a molar mass, may or may not be molar ratio. What does come first is X line, drag down the unit, and then set up the ratios to solve for what you need. Take some practice. It does take practice. Keep trying, and you can do this.